Good afternoon, everyone. Welcome to this session entitled From Climate Models to Farmer Decision Support, an Introduction to the Dawn Project. I'm Christopher Neale. I serve as the Director of Research of the Dougherty Water for Food Global Institute here at the University of Nebraska. And I welcome you all to this session where we are going to discuss this USDA NIFA funded project, Dawn. And we have several short presentations from different members of the team that are going to explain what Dawn is about and where we are in the timeline. And then we will move into a panel discussion where we've invited 3 panelists to listen and then comment on what their thoughts are about water and nitrogen management in the Midwest, and in this case specifically in Nebraska. So we're going to start off then the session with a presentation by Dr. Xin-Zhong Liang. He is the principal investigator of the Dawn Project. He's at University of Maryland and a professor there, and the leader of this effort, which is quite large and involves many moving parts, many universities and co-PIs. And so I'll pass the word to Dr. Liang so he can give an introduction about what Dawn is all about. Dr. Liang, you have the floor.
Thank you. Thank you. Let me share my screen. Thank you, everyone. Thank you all really very much to give me an opportunity to introduce the Dawn project. Dawn is funded by USDA NIFA, and the more detailed information you can find in the Dawn's website, dawn.umd.edu. What the Dawn is about, develop a dashboard to improve agricultural water use and the nutrient management to sustain the food, energy, crops production in the Corn Belt. So I will spend a few minutes here to briefly introduce what this Dawn project is about. So Dawn, as so Chris has mentioned, that it's funded for several universities. Actually, this involved the University of Maryland, Illinois, Nebraska, Minnesota, and Colorado State University, and the Family Farm Group. So with many co-PI and investigators. So the main goal of the Dawn is to create an infrastructure that can integrate advanced science and innovative technology to provide credible and usable information for agricultural producers and water managers in order to improve their land, water, fertilizer use synergies. So this will involve complicated science modeling and making reliable prediction, and then provide these decision support systems that are actually tailored to user need. So there is also involved information delivery system that can provide the user tailored information as they making decisions. To do that, we would like to accomplish 4 key objectives. First is try to engage agriculture, producer and water managers to work with us together to co-develop the system. We then need to build the coupled science model system that can represent all kind of interaction among the climate, agriculture, land, water use, economy, environment impact, so that we can get these scientific information toward the user decision. We then need to make a reliable forecast. So only when these forecasts are being accurate enough or sufficient that the user will use and be effective. Then we also wanted to educate our next generation for them to carry on in this kind of work in the future. So we separated several of the teams, divided into several key teams. The first team is the extension team. The extension team is trying to proactively establish the extension to engage stakeholders for co-production of the system. So we will start to build, for example, stakeholders working group, and so that these persons will be very actively work with us. And we need to develop decision calendars to know what exactly these stakeholders are looking for and what is the metrics they are actually use in their use of this system. Then we would engage these stakeholders to use this information. And finally, we will actually expand this information use across the whole Corn Belt. So with that, then we are currently not only, and in the coming 5 years, we are not just targeting the broad stakeholder leaders, which is mainly the agricultural producers, water managers, and policymakers to deliver reliable regional scale decision support information. But also we're actually targeting engage the farmers to provide usable tools for them to test and for their local decision-making processes by individual crop growers. So these are the locations, for example, many of the farm from the family farm group actually will work with us to test the system. With that, these complicated system, it's really require a supercomputing, very complicated, and it will not be able to deliver in the timely at local scale. So we would need to really develop not only just these local scale, but these local scale action actually will affect the larger scale, like the regional climate and hydrology, all these. So we need to embrace all these together. That's why we need to develop the system in a more complicated way than the local scale. With that, using this system, we would develop that system and make a seasonal outlook. And this will be updated like monthly. And that will be downscaled from the NOAA's current seasonal climate forecast and at a lead time of 1 to 9 months. The second stream is short-term forecast. It will be updated daily for real-time operations, and they are again downscaled from NOAA weather forecast at a lead time 1 to 16 days. All these system predictions will be made at approximately 1 kilometer resolution in Corn Belt and 15 kilometer over the corners through the multi-nesting grids. It's not only the resolution will improve, but we are also will be delivering the climate weather system information like NOAA, but more so we will deliver how the crop react to this climate and how the hydrology or the environment like water quality will relate to these agricultural productivity, and also how the risk the farmer may need to how, for example, economy and the price. So that is a system we will accomplish. So with that, we needed to deliver also the decision support system that can be relatively easy to calculate, don't require to run the full system, but contain the accuracy enough for the user to making decisions. So currently in our tool is a transfer research to dashboard, including irrigation scheduling. This is suitable for field work, crop yield estimate, risk analysis, fertilizer, and nutrient management, and more actually in plan. And this will be progressively in year by year. So with these system developers, then we have to deliver this information for the users to actually use them effectively. In particular, we needed to provide a very good information delivery system, which will allow the users to explore various management options, assess their economy, environment, and consequences, allow the voluntary information sharing among users. so that the user can see and learn from previous query simulation decisions and responses by other users. This will also allow the DOM to collect user statistics and feedback, including the evaluation and need assessments that can refine the system production further. As an example, currently we are launching the GDD tools. In addition to what is currently available on the market, on the static information, we share, for example, what is the 30 years data in the history, or even 40 years in the history, what does the GDD look like during the year. But what more important to us, we are editing the dynamic features, the prediction feature, not about the past, but the prediction of this year before the farmers starting their project in 9 months ahead, for example, including the progress of the crop phenology, like a planting date or harvest and the growing days. But also we'll have this allowed the user to enter different kind of scenario. For example, we will say, okay, we are planting 4 different crops. What these risks will be, what the benefits of. That will be the dynamic prediction. Last but not least, we need to educate the next generation leaders in sustainable agriculture, water use, and nature management. I'm going to stop here. So for the next few talks, the different leaders for the different group will give you more detail about each of these. Thank you very, very much.
Thank you, Dr. Liang, for that great overview to kick this off. And so we will, we're running right on time here. So I think I'll move ahead to the next presentation. I think as the team presents, questions are going to arise, right? So the next speaker is Dr. Ximing Cai. He is the Colonel Harry F. and Frank M. Lovell Endowed Professor in Civil Engineering at the University of Illinois, Urbana-Champaign. And he's a co-PI in this Dawn project and is in the decision support system team. So Dr. Cai, you have the floor.
Thank you, Christopher. Hi, everyone. So in the next several minutes, I'm going to introduce the work on decision support system. As Liang already introduced, we have a team on the development of the DSS, and we work within the team, and we also collaborate with other teams such as extension, education, and information delivery system. So when we talk about decision support system, we refer to an integration of data and information models, and also the interface with the users. So regarding the models, so we have several teams working on different models, which would be incorporated into the decision support system. So now in the following, I'm going to introduce some progress from different teams. All right, the first is on irrigation scheduling, which is conducted by a team at University of Nebraska, led by Professor Christopher Neale. So you can see here, this work is based on the long-term experience of the group. So they basically combine the remote sensing-based crop evapotranspiration assessment, soil moisture assessment, and based on that, they could estimate the crop water requirement and also the water availability, and then they could determine the irrigation requirement at a particular time. So this tool has already been developed in the GIS environment. Then it could handle spatial data. And also the code is open source, then it will be available for the improvement by the public. All right, sorry. So the two versions, the GIS version and also the open source version, they have been tested during the 2021 growing season on several center pivot irrigated systems. So the figure here shows the seasonal soil moisture depletion for variable rate irrigation equipped center pivot technology. Alternatively, a team at the University of Illinois, led by myself, we are developing a real-time irrigation scheduling system. So the purpose here is that we hope we could estimate the irrigation at a particular time based on hydrologic and agronomic modeling. So we're going to bring some observations through data simulation technique, and then we could have more accurate biophysical simulation. And we're also going to incorporate forecast. That's the work from Liang's group, and then we could consider about the uncertainty feature and how that affects the current work. And one particular thing I want to emphasize is that since we're going to deliver a real-time scheduling tool, so our modeling results will be provided to farmers at a certain time point for their consideration. They can use it or they can just use their own. But then the next time period, modeling will be based on the actual irrigation. So we have already done the testing with a synthetic case study. So the result here, you can say, basically we show with or without data simulation. So the results might be quite different. And and also we tested in this kind of hypothetical case, we just assume we could work with some farmers for their adoption or not adoption of the results. And for the case study, we showed this irrigation system can increase the profit significantly. So right now we're working on a real world case. This is Eastern Nebraska maize. We're going to test this with 2019. And so also we have some measurements on water content at several depths. We also have the canopy, the observation of the canopy cover, and the 3 days forecast at this moment. So we are doing the model calibration, and so we are getting not the final, but some reasonable results. So once the model is calibrated, so we're going to incorporate this with an optimization framework, and also with the interactions with the interface with the farmers interaction. Then we could test it for a real world case. So for the crop innovation, the purpose here is that we want to consider advanced crops. Besides the regular crops, corn or soybean, we also consider about the potential perennial grasses. And we combine a crop growth model with a regional or national economic model to assess the benefit, both the environmental and economic benefit of different crops or different crop patterns. So the particular research here, they work on how could we, by working with hydrologic team, we could improve the crop model by considering soil moisture dynamics. And also we are considering to make this capable to do forecast or predictions. So the water quality team is led by Professor Xin-Zhong Liang and with several others. So currently they try to calibrate the model and use the model to predict future nitrogen availability using climate forecasting, and also determine the best fertilizer practices to ensure crop yields while minimize negative environmental impacts. So they have already collaborated with other teams in the project, and one of the purposes is to develop some fine scale data, like on-farm research network database, and then that could be used to improve the model. And the other one is to look at the particular sites to test how different nitrogen application rate affects the crop year. So, all right, let me say a few words about our data management and the interface team Liang has already talked about. So basically that team, they're going to deal with like a physical, a hard and the software system, which could handle everything from the project. So system includes the hardware, software, and data management functions, and also some software development functions. So the major purpose here, as Liang already mentioned, the major purpose here is to host our models, our data and information into a dashboard, and then this interface team will develop data exchange and also data management procedures, and also the interface with the users. And particularly, they have to resolve the difficulty of embedding different models with different scales, different complexities into a common platform. So we have been working with extension and education team because we know this is important in order to make the DSS useful. And so each of our team made a single slide to show what we could provide and what we would need from the extension team or from the stakeholders. We have a lot of ongoing work, so I will not go to details on this, but overall, the DSS team we're going to focus on several things. We will complete the data from the various models, and also within the DSS group, we're going to work on the model integration. So for example, the crop growth model, the integration of that with the economic model and other models. And so right now we are working very hard to build some of the tools into DSS dashboard. And we still want to enhance our communications with the extension and education team. Thank you very much.
Thank you, Dr. Cai, and for that explanation. And we're right, we still quite on time. Everyone's sticking to the 10 minutes. So we will continue with a presentation by Jonathan Straube. He's a research associate for computer system administration at the Natural Resource Ecology Laboratory at Colorado State University. Mr. Straube is also a member of the DORN IDS team and heavily involved in all the computer modeling and programming and so forth. So Jonathan, you have the floor.
Thank you very much for that introduction. I'm sort of presenting on behalf of Dr. Gao, who's off teaching today, who is the co-PI lead of the IDS team here. But I'm also presenting on behalf of a talented team of dedicated individuals from many different disciplines. We have information technology specialists, full stack web developers, agricultural modelers, database managers, user interface experts, and of course, ag producers and water resource managers. And that's quite a diverse group of stakeholders to be developing an ag production tool. But this is simply not just another tool for the farming community. It's a decision support system to aid producers to achieve goals beyond just the current growing season. There's already many tools available for producers and water managers. We have spreadsheets, climate maps, and there's even some very good online tools. And they're very useful for guiding decisions to be made in the field. But many of those decisions still rely on 7-day forecasts, instinct, and past experience. And with Dawn, we're sort of integrating a lot more tools into that. We're using advanced and localized weather forecasts from Seawharf, decision support tools, AI predictive models. We're going to have almost a petabyte of crop and climate data behind us, observations, real world observations, and a full stack of hardware and software dedicated to the Dawn platform. So in other words, we are developing Dawn around fast and scalable architecture and not simply taking a model and making it work on whatever we can put it on. You know, in the words of the Aladdin genie, you know, phenomenal cosmic power in a little itty bitty space. So that's sort of what Dawn is about. So the goal is to not just to help producers with forecasts, but with decision support and risk management. And so how do we go about doing that? You know, in a traditional development cycle, you meet with your producers once, and then you do your development, you're off away in your little black box, and then you meet with them at the end and you say, here is what we presented based on what you said. Well, the way we're going about development of the interface here is that, you know, the Dawn, we don't have any rigid specifications. Nothing is hard to find. You know, we want our stakeholders to help create what the output should be. So instead of meeting with them once and then later on, we will continuously engage with ag producers and water managers through the extension team and get their feedback. And we will continually improve Dawn tools and the information they receive in each iteration, adding value at every time. And that's called the agile approach. And since, you know, the development team is in Maryland mostly, and in Colorado, we're not going to have direct access to our stakeholders. So how do we figure out what they want? Well, we build user stories. And how do you build a user story? A user story is who, what, and why. And this is a means for someone we'll call the product owner to understand the motivations of our stakeholders, because we can't just keep asking a stakeholder every time what they want. They may change their opinions or what they want. So we use a product owner to sort of act as that interpreter. And at each step, we're not going to only gain information from our stakeholders, we're also going to be adding value to the stakeholders. So take this, for instance, as a user story. You know, a farmer wants to know when he wants to freeze, right? It's getting at harvest time and, you know, very valuable information to know. But that doesn't give the development team very much to go on. Okay, we can develop that story. We can have our extension people find out, what is your motivation for doing that? Okay, they would like to gain, you know when they need to harvest. Okay, but we can push that a little bit further. We can have them define what that means. You know, maybe for this crop, 30 degrees is the cutoff, not 32, or maybe it's 28. So now we have a little more motivation. As we keep expanding and exploring within our relationship with producers and water managers, you know, we figure out consequence. And then finally, at the end here, we have something our development team can take with us. You know, we have parameters set up, we have consequences and economic outcomes. So we know motivations of why they want to do something. You know, one other important factor in creating a new tool like this is going to be a trust factor. And we're going to make that a priority here. Because once you lose trust, it's very hard to gain back. So, you know, we see a test drive here. A lot of people get a great deal of fear for signing up for anything, whether it be a subscription service or whatever. So we want people to go in and see what Dawn has to offer, before they have to, log in and share their information. We also want to be forthright and disclose with them, where our tools are coming from, what we're collecting, and what we're doing with the data. We don't want this to be a black box, okay? We want producers to know what they're using and how it's going to be used. And hopefully, once we've gained their knowledge and trust, we can get additional information with them and also share additional information. A forecast is great, but when you can start to put it in a historical context and you add motivation onto there, you end up with a powerful tool that not only changes your decisions now, it will change your decisions in the future. And I think I'd like to call that sustainability. And we talked about motivations here. What are your motivations? Maybe for somebody, they want to maximize yield. Maybe they're using it, their crop on the farm, and they need to maximize yield for feed or something like that. So that will be one motivation. What if they want to maximize profit? Maybe it's a different seed, maybe just moisture content, different harvest times, right? Okay, that's a different motivation. So this is not only forecast what you're going to achieve, but also helps you take in these other things, your true motivation in what you do, okay? There could be, for instance, a lack of resources of water or fuel. You might have to take a no-till approach or something to agriculture to be able to be more economically viable. And that helps our producers reduce risk. And, just like a Google map, we're going to take a journey. We're going from University of Maryland to Jacksonville, Florida, right? Here's one route we can take. But once we find motivation, what if the motivation is to see every lighthouse along the way, okay? That is drastically going to change the approach that we take and the journey that we take. That's why we want to identify motivation as well as, crop types and what the climate is going to be. And one of the way to do that is to look at alternative strategies and to help producers manage risk. Farmers are a people of generally of great hope. It's called, if it was a sure thing, it'd be called business and it wouldn't be called farming, right? You have markets, weather, climate, energy costs, pests. What you need to do is present to producers and water managers a series of alternatives and let them make the risk, not the risk, but the decision on which risk they want to take and which they want to avoid. And the dashboard is going to be designed to help them do that. And in agriculture, your informational changes with the seasons as well. So, maybe in the spring, you want to know a long-term forecast and you want to be able to select different crop varieties for that. At harvest time, you may be interested in a more detailed forecast, more immediate. What's going to happen in the next, 10 days, 2 days, when you have your crew available to work and do the harvest, or whether the soil is going to be able to support those types of activities. So you also want to change your outlook depending upon your individual seasons. So in conclusion, we are going to be developing the dashboard in co-production with producers and water managers, along with the Dawn team. Their input is critical into how these tools will look and the information that they give. And the way we do that is by taking an iterative approach. And each time that we make changes, we're not only just making changes in which things look, we're adding value to the information that they get. So Dawn is not simply just a decision-making tool. It helps them manage risk and make long-term decisions. And risk management, I quote with, sustainability. And, you know, farmers are highly motivated to keep farming. You know, sometimes profit is not necessarily the ultimate goal, but they're out there taking those risks and wanting to continue on in their practice. So in conclusion, I'd like to sort of thank the IDEAS team for all their hard effort and work and what they've done.
Thank you, Jonathan, for that illustrative description of the challenges. The next speaker is Dr. Melissa Kenney. Dr. Kenney is the Director of Research and Knowledge Initiatives and Principal Environmental Decision Scientist at the Institute of the Environment at the University of Minnesota. She's also the lead of the extension team within Dawn. And so, Melissa, it's all yours.
Thank you. It's so good to be here. And I really applaud you all for thinking creatively about how we can all be together during these times. I do hope that in the future years we'll be able to gather together. So what I wanted to do today was just give you like a very, very high level introduction to some of the extension philosophies and activities, and then leave time for discussion and questions, because I think so much of it comes out of conversations that we might have. So why do we even care about forecasting, and why is extension involved in this? So I think it's actually super useful to note that when we're talking about decisions, and a lot of extension is related to engagement to help people make smarter decisions based off of the goals that they have, not, you know, some academics' goals. When we're talking about forecasting, is all about the future. It's all about near-term information that is designed to help make smarter decisions, because decisions are all about the future. We're not making changes in the past, we're all looking forward. And that's actually a really fun place to be, because those choices are really what determine the pathways that we might pursue in the future. I think oftentimes when we think about this and we really focus on some of the forecasting capabilities or the dashboard, part of what we want to contextualize is that when we're talking about decision support and extension, it's those tools and the dashboard, the models, the specific things that we're doing and producing in terms of information sources are absolutely critical. But just as critical are the decision support processes that we use to engage people, both in terms of like the co-production knowledge that we talked about, but also in terms of the training, the support that we're providing, the way that we contextualize this information to the decisions that they're making, because ultimately the combination, and it's almost always a combination, both processes and tools are necessary to produce, you know, short-term outcomes related to helping people make trade-offs and assessing risk, but also some of these longer-term decision-making outcomes of, you know, building understanding related to relationships, as well as better understanding and engagement related to problems, objectives, and choices that one might make either individually or as a community of users. So when we talk about co-production, I think it's just useful to maybe discuss a little bit about what we mean by co-production, because a lot of times when these projects are developed, we oftentimes think about this push out of information, of what information have we produced as scientists or as university people that needs to go outside of the university realm. We also talk about sometimes like we just need stakeholders to tell us what that information is, and we'll shape our research priorities. We're talking about co-production. It's both this push and this pull. It's understanding maybe what exists that has been, that can be developed, and helping to share that out into the world, and also engaging, as was talked earlier about sort of these user stories, and as Liang was sharing, some of the decision calendars, to be able to better understand some of the stakeholder needs, the decisions that they're making, and the information gaps that exist now that could be filled through forecasting systems. And that's exactly what we're doing. Our extension team is co-building, testing, and evaluating Dawn so it can be tailored to the needs of stakeholders. More or less, we want to know what you want to know, so that we can better improve iteratively the way that we're constructing forecasts so that it can be useful in supporting your decisions. So our vision is to deliver relevant and more accurate information to users, aid farmers and water managers by reducing uncertainty in short-term and long-term planning, to support informed decision-making for all agricultural and other stakeholders, to help ensure the most efficient use of natural resources, to build user capacity through active and regular engagement, to provide open access Dawn tools to all who choose to use it and want to customize it for their own uses, to act and build upon regular feedback and engagement with our stakeholders, to reduce inefficiencies for farmers and water managers so they can make smarter choices, and to demonstrate effectiveness through transparent dashboard development. This is what we really are aiming to do as part of our extension dashboard vision. So our team composition, we are over 20 people across multiple institutions, and we have 3 areas of particular expertise. We have experts in dashboard design, and Jonathan, you did a phenomenal job of sort of setting up the importance of that and that user-centered approach to how we think about developing these decision tools. We have extension specialists who are just phenomenally expert in farmer and other stakeholder engagement and developing programming and trainings around that. And we have a really innovative decision support research arm that is doing groundbreaking work on testing visualizations and engaging with users and doing critical decision calendaring exercises to think about this push and pull. We've talked about the collaborators, and our extension collaborators span across all of our different institutions. So it really is an important component of the Dawn project. And the process that we use to sort of guide our approach is that we engage regularly as part of our regular networks and networks that we're building: farmers, water managers, crop consultants, other stakeholders. And from those stakeholders, we're really seeking to understanding gain insights about decisions, informations, gaps, barriers, and where the tension points lie in the deployment of precision agricultural approaches. That information is fed back through our extension and our decision support and design teams, and then activities that they're doing feedback to our stakeholders in this iterative loop. Additionally, we use that to deploy iterative design. We really are trying to match the science, the prioritization, the design and translation of it, the creation of these tools to really meet stakeholder needs. And that means active collaboration with our modeling teams so that we can produce decision support tools that match to needs and really address some of these core biophysical and social science questions. So a couple of our extension highlights were really building a team in a remote environment across a community of folks who hadn't engaged together previously. We spent a huge amount of time maintaining current relationships with stakeholders, starting to build new connections, and starting to scope our stakeholder working group. We also spent time engaging with our existing stakeholder extension experts, as well as looking through the literature and reports to really understand within the region, what are some of the key priorities that are being stated by our constituents. And Jonathan already went through some of the philosophy and approaches to dashboard design that we've been pursuing. And so in terms of coming up, what's coming up, a number of the activities that we lay out are continuing activities like stakeholder engagement. It just ramps up to a completely different level as we start to have dashboard tools that can be deployed. It means that we are going to be deploying a stakeholder work group. We're going to be engaging stakeholders and sharing what's happening through Dawn training and other activities. And we're also going to be starting to identify who might want to be collaborators with us to understand what works and what doesn't work in terms of integration into firm level decisions. We're also doing work right now on formalizing the scientific needs of stakeholders and the Dawn user priorities. We're just started a project conducting decision calendars. We're doing a deep dive literature review that will come out, be submitted later this month, that will really help us to shape a number of the research priorities. Jonathan talked about the dashboard, and I think one of the other interesting and important insights is the use of a flexible API system that allows us to integrate into field software tools like Field IQ. And then we are just now about to hire a communications manager who is phenomenal, who will be helping to launch a number of different ways of being able to communicate what we are doing more widely to the community of folks who are part of our Dawn network. So how you can get involved, and I'll put these in the chat. If you're interested in being on the stakeholder working group, you can nominate yourself or others. Please help to share priorities that you have for Dawn, or help be part of a group that might help to test Dawn. And then finally, keep up with what we're doing and see some of the opportunities that might arise for you to get involved by signing up for our newsletter. And again, I'll share these over chat so that then you are able to send us emails or sign up on the forum. Thanks.
Thank you, Melissa. Thank you very much. We will move on to the next presentation that will be done by Dr. Amy Sapkota. She's a professor at the Maryland Institute of Applied Environmental Health and director of the Conserve program, which she will probably discuss here in her presentation. It's a center of excellence at the Nexus of Sustainable Water Reuse, Food, and Health. She's also a co-PI and lead of the education team within the Dawn project. Dr. Sapkota, you have the mic.
Thank you so much, Christopher. I'm delighted to be here with you all to share a little bit of information about our Dawn education initiatives. So in this short presentation, I'll review our education team and mission. I'll talk a little bit about our undergraduate summer internship program, our undergraduate courses, and our graduate student professional development workshops. So let's get started. I first wanted to introduce the Dawn education team. We have a fantastic team of folks working on our education initiatives across all of our participating Dawn institutions. And many of our education team members are also integrated into the research of Dawn, which is a really fantastic way that we've set it all up. In terms of our mission, overall, we want to advance experiential transdisciplinary educational programming, and we're aiming to inspire our next generation of leaders in sustainable ag water reuse and nutrient management. And our overall educational approaches have many different themes that I've shared here. One big theme that you can probably sort of already understand from the diverse research ideas that have already been presented, as well as the extension approach that Melissa just presented, is we're really focusing on interdisciplinary research. when we want to, as we move forward through time and we want to solve these very complex food and water challenges, we're going to need all disciplines on the table. And we really want to train our next generation of researchers in interdisciplinary research. So how can they best communicate across disciplines? How can they improve their communication skills, including oral communication and written communication, so that they can effectively work with diverse stakeholders and folks from different disciplines? Another emphasis of our programming is to improve skills in systems thinking. So obviously here with the Dawn project, we need to think about water systems, food systems, climate, and modeling. So much comes into developing the dashboard, and a systems thinking approach is really needed. We're also focused on the professional development of our students, increasing cultural competencies, leadership skills, and there's a very strong emphasis on increasing diversity across STEM fields that are associated with the Dawn project. So across all of our educational programs, we are really advancing underrepresented minorities and also women in STEM fields. So now let me move and give you a brief description of our undergraduate summer internship program. So this is a joint collaboration with the Conserve Center of Excellence, which I direct at the University of Maryland. So the Conserve Center focuses on advancing agricultural water reuse. So it's very much in line with sort of overall missions of Dawn when we look at how we can improve sustainability at the food, energy, water nexus. So in terms of the summer internship program, this is an 8-week program. It's a funded program where we offer $5,000 stipends to our undergraduate students. This past summer, we had 12 interns, 75% of whom were women, and 6 universities were represented in that intern cohort. As I mentioned earlier, we're not only focused on our interns participating in research, extension, and education projects, but we also want them to develop their professional skills, their writing skills, communication skills, and they also engage in journal clubs and seminars where we bring in guest speakers across the Dawn project and really across the nation and the world, speakers who are focused on the research and extension activities of Dawn. So to check in and see how we're doing with the program, we do an extensive evaluation of the program. We do mid and end of program surveys so that we can check in and see if we are achieving our goals. So here I've just listed some examples of our summer internship projects. I couldn't include all 12 projects, but I wanted to provide some examples of one of our extension projects, as well as several of our research projects, so you could get a sense of what our interns have been working on. So with Melissa at the University of Minnesota's Institute on the Environment, we had one of our interns working on a stakeholder scientific needs assessment. At the Dougherty Water for Food Global Institute, we had an intern analyzing satellite imagery and evapotranspiration data in support of the DSS team. At the University of Illinois Urbana-Champaign, we had an intern that was developing and using computational models to evaluate food and bioenergy crop development. And then here at the University of Maryland, we had an intern that was developing modules that use observations and climate model output to predict environmental and agricultural outcomes. So you can see the diversity of extension and research projects that are included in the summer internship program. I'd also like to shout out our 2021 summer interns. Here are all 12 of them. Again, they came from 6 different universities, really a fantastic group of bright undergraduates, rising stars. And one really wonderful thing about the program is what we aspire to is that we develop relationships with these students, and those relationships extend beyond just the 8 weeks of the summer internship program. So yes, they have this discrete time with our team, but the idea is that we establish more long-term relationships with the Dawn team members, where in some instances, some of the students have continued with their projects throughout the fall semester. And then we really support the students remaining connected with their mentors so that they continue to receive career advice, particularly with regard to the decision to either go to graduate school or go out and begin working in the field. So moving on to our undergraduate courses, we have two different courses that are supporting the scientific disciplines that are included in the Dawn project. We have a course that is taught by Reed Christensen at the University of Illinois Urbana-Champaign that's focused on looking at how important agriculture and the environment are to our society, and really sharing with the students how each of these important areas influence one another. Here at the University of Maryland, our second undergraduate course is really focused on the water and food interactions. It's taught by Dr. Lina Malayal. And this is an in-depth interdisciplinary study focused on the public health issues associated with water used for food production globally. In terms of our graduate students, we obviously have many graduate students and early career professionals who are working on the Dawn research and educational approaches, but we also want to make sure that we are helping these students increase their professional skills as well. So here we are leveraging the University of Maryland Global Stewards NSF NRT. This is a program that's based at Maryland that I direct. And our overall aim of this program is to train future change makers at the Food, Energy, Water Nexus. Liang is a co-PI of this program, so it's very much integrated into the Dawn work as well as the work of our Conserve Center. And as part of Global Stewards, we offer annual Summer Boost workshops. And these are really intensive workshops focused on a number of different types of professional skills. So this past year, we had sessions, this is just a few of the sessions, focused on how do you effectively communicate with the press. We focused on professional mentoring, how to write an effective op-ed, and also we had several intensive units on grant writing, management, and budgeting. So this gives you an idea of what we have been up to in this first year. As we move forward, we would like to work with our extension team to plan outreach and service events, hopefully focused and including 4-H kids as well as K through 12 kids. This is something that we were not able to do during the pandemic, but we were hoping that we at least have one service and outreach event at each Dawn participating institution in the coming year. And finally, I would like to end by thanking our team members. First of all, our fearless leader, Liang. Thanks so much for bringing together this incredible team. I think we have an awesome mission, and I'm super excited to see where the project will go over the next 4 years. And I'd like to also thank the Dawn Education team as well as the Conserve team. And I'm happy to take any questions later.
Thank you, Amy, for that. We are sort of slowly drifting in time. I'm the next speaker, so I will go ahead and share my screen. See if I can get this thing going. I will fly through my presentation. I presume you can all see that. Is that right? Yep.
I don't see your screen.
Okay.
How about there?
Here it comes.
All right.
Okay, here it is.
Thanks.
Good. Thank you. I did have to do that last step of sharing the button. Anyway, as I mentioned, I serve as the Director of Research of the Water for Food Institute. Our team here in Nebraska consists of several people, Leila Puntel, Laura Thompson, Roger Elmore, and Guillermo Balboa from the Department of Agronomy and Horticulture here at UNL, Joe Luck, who's in the Department of Biological Systems Engineering, and Ashish Masi, a research scholar here at the Institute, Sammy Akashe and Mitch McGuire are postdoctoral scholars. All these folks are working on Dawn. And Dr. Yoon Yang, who's a visiting scientist at USDA RS, Hydrology and Remote Sensing Laboratory. So I'm going to just quickly go through what our Nebraska team is involved in Dawn, and you've heard a little bit of that from Dr. Ximing Cai, right? The SETME model he mentioned, this is a hybrid model using remote sensing as inputs. We run an energy balance model using the thermal IR band along with the multispectral bands of the satellite or UAV systems or airborne systems. And then we have a water balance model as well, where we use the remote sensing to update the crop coefficient, which is used to obtain the actual ET that you need in the water balance of the soil root zone. So this model has a hybrid approach where we can use results on one to update the soil water content of the other. Dr. Cai mentioned that the model is now being ported to an open source so it can be incorporated into the Dawn decision support tool. And I want to mention that we have used this model to do irrigation scheduling in pivots, many different center pivots here in Nebraska, and particularly variable rate irrigation equipped center pivots where you can apply the water differentially in each zone of the field, and the field is zoned according to soil characteristics, water holding capacity, previous season productivity, and so forth. So we use all these inputs to zone the field and run our model so that we can apply the water differentially on the pivot. So we develop the prescription, upload it to the pivot computer brain, and it applies the water differentially. And as Dr. Cai mentioned, this is a soil water balance. We have these graphs for each zone individually, right? So we're keeping a water balance in each zone so that we know when to irrigate and apply what the crop needs. Now, we also leveraging another project, our Global Daily ET project, which is partnering with USDA, the lab that Dr. Yoon is working at, NASA, University of Maryland is a partner here as well, and the Drought Mitigation Center here at the University of Nebraska-Lincoln, where we're running the Alexi model by Martha Anderson using VERS, which is a new satellite that's a follow-on to MODIS. And the project started in the Middle East, North Africa region, as you see here in this slide. And we run the model on 15-degree grids. Okay, so you can go to this website and look at the data and register if you want to download anything. But we're also running the model here in the Midwest, right, in the tiles that relate to our Dawn project and other projects that we have involved. So here's the tile 54, and here's the detail of Nebraska for June 16, 2017. Now, this is at 400-meter level. That's quite coarse. This product is good for water balance in an NRD or in a watershed. But to do irrigation scheduling at the field level, we need to downscale that using the DysAlexi model and a Python version, which is an open source version of this DysAlexi, which Dr. Yoon Yang is presently porting to the Google Earth engine. And so you go from the 375, 400 meters to 30 meters using Landsat imagery. And now you have a lot more detail and many pixels within the field to work with. Another part of our involvement is the Nebraska On-Farm Research Network that's led by Laura Thompson on the team. And this has support by the Nebraska Corn Growers Association. You can see the different institutions that are involved in this effort. And this is about collaborative opportunity between farmers and researchers to test different approaches, different technology, different things, right? Dawn would be one of them, right? So this is using real farmer operations, right, at that scale. Right, and by working with the on-farm crop consultants, the Nebraska irrigation consultants and researchers, they work together with the farmers to apply these technologies. So this is on-farm experimentation, and you see here the sort of principles of this, right? It's farmer-centric. We're doing the research on farmers' fields. We're using data and the insights from the farmers themselves and their feedback. The experts from the university and industry partners add value. we learn together, okay, and then we scale it, right? And this question is, how do you get more farmers involved, right? Well, by having the expert partnerships with UNL Extension and by crop industry consultants and crop consultants and so forth that are involved, right? You can share and discuss the results, right? And this is very important, right? For learning process, right? Farmers can and the investigators learn together in this process and produce a better product and how to use the technology better, right? So it's just some data here from the experience from the on-farm network. 75% of the farmers that are involved in a network end up using the practice in their day-to-day operations or the technology that they're testing. And more importantly, they share their results with some other farmer, okay? And this is very normal in many parts of the world. Farmers are looking over the fence to see what their neighbors are doing or their friends, right? And this is very important. And then, of course, there's been a profit increase by the farmers in the network for using these different technologies and so forth. So we're going to be using this network and farmers that are involved to test the Dawn decision support system and get their feedback, right? So our plans over the next year are to deliver this open source version of SETME to the decision support team for programming. We're going to continue testing. We're going to coordinate our irrigation scheduling tool with Illinois and identify farmers to test the irrigation scheduling and conduct tests over the next growing season. And then our team is also going to interact with the extension group, with stakeholders, do workshops over the winter to present the Dawn decision support, the beta version, get farmers involved to test it next week, get their feedback, right? And so we're going to have to produce some events over the next winter. Hopefully, with the COVID going down, we're going to do in-person events, and that's always more productive to talk one-on-one with farmers and have them in groups. And then our group is also working with the decision support system group by providing expertise on crop management, rain-fed and irrigated. Nebraska is a big irrigation state, and provide data from what we have here to test and develop a nitrogen decision tool that is important for the Dawn, right? And put these nitrogen models to use. So thank you. I will stop sharing, and I think now we will move on to some quick answers to some questions that are out there. A couple of questions before we move to the panel. The most important part of this session is getting the feedback from our panelists and what they learned today, right? So there is one question, which is, does anything like Dawn currently exist? Or is this a completely new endeavor? What makes Dawn unique? So I'll direct that question to Dr. Liang for his observations.
Yes, I already have posted my answer in the chat. As far as we know, the Dawn is the first project ever co-developed with the stakeholders, and actually, and also incorporate as a forward thinking, forecast mode, including even for these GDDs, we are not just happy with the past, but we are actually forward to predict. And many of the information we are dealing with, like will deliver, like irrigation scheduling, nutrient management, and all that will be new from both the system prediction point of view, also from how the information will be packaged and delivered. So we are actually providing this information, not just static. It's more like dynamically work with the users so that they can make a judgment. For example, if you are planting something, we will help them So when you plant differently, what does the result will look like? And giving all these information to help them to making a more reliable decisions effectively. So my answer is yes, the dawn is new, and we have many unique things to show.
And perhaps you could answer the other question on the timeline and when will collaborators likely to see the dashboard live and being used by producers?
Yes, the dashboard will live in a month, which I think is already scheduled. So we first the dashboard tool will come up with the GDD tool, including the crop progress information that, and this will, of course, will continue to be improved. And then the next in our plan is irrigation scheduling, which we are planning to launch in 6 to 8 months. So we are currently in more like in the initial deployment, like how to get the dashboard design, all that is working on. The model is already being tested and we are ready to go. And the others like days to field for the suitable for field work and the nutrient management all will be announced in the dashboard for the coming.
Thank you, Dr. Liang. I think I'd like to move on to the panel now and introduce our panelists. Our panelists are Mr. Rorik Pohlman, who's a producer, owner of Pohlman Farms, right, in near Sutherland, Nebraska. He's a member of a DWFI International Advisory Panel. Mr. Brandon Honeycutt, a producer from Gitna, Nebraska. He's a member of the Corn Board as well. And Mr. John Berge, he's the general manager of the North Platte Natural Resources District here in Nebraska, and of course works with hundreds of farmers within his NRD and has a good perspective from that point of view. So my first challenge or question to the panelists is, well, I know there's a lot of information that you listened to this morning. How do you view a tool like Dawn being useful in the production side of things, right? So I pose that question to Brandon and Rorik, whoever wants to go first and take a stab at it.
Go ahead, Brandon. Yeah, you know, Dr. Neale, that obviously there is a lot of content here, and a bit of a takeaway for me is the delivery. I'm not picking on anyone in particular, any process, but a lot of the background noise, that all this collaboration to build this concept and idea is huge. But it boils down to, one of the things I took away from Melissa was this putting together somewhat of a comms team, a communication piece that goes beyond just simply telling our story and communicating it to producers. It literally is how do we expand that relationship and connectivity with the public, and also with the people that are going to making bigger decisions about a regulatory framework or new and understanding the difficulties and challenges within a stewardship and conservation driven piece, which ultimately is what you're looking at, is how do you roll that all up into a very simple and straightforward piece. So that's my initial takeaway.
Thank you, Rorik. Brandon.
Yeah, you know, as watching the presentations and really thinking through the whole concept here, is there's from a producer standpoint, we have all these different tools out there that we try to mix and match and try to make decisions on. And you know, it's never been an easy process because you're not really sure. You know, we've got irrigation in groundwater sensors. You know, we have the decision tools we're making for nitrogen. We're trying to go out there and find other information, and having a place we can just bring it all together and help in that decision-making process will be huge, because there's a lot of those times where, you know, we're doing as good of job as we can, but then also when we overlay that within the on-farm research network, which which we've been a part of on our own farm, and obviously saw the Nebraska Corn Board is a proud sponsor of that. Having that feedback from farmers on the ground within Nebraska, specifically saying, okay, let's see how this works. Let's compare it against whatever you're already doing. I think that's going to be big, and it looks like a very giant project, and appreciate everybody putting it together.
Thank you, Brandon. Now, John, I'd like to get your comment feedback, but also because NRDs have a very strong convening power within your domain, right? What is the best way to engage farmers in your NRD to show them Dawn or get them involved, and so forth, beyond the on-farm network that's being described? Go ahead, John.
Well, first, let me say, I think that everything that I just saw offers some great promise. As most water practitioners will at least spout, I don't know if they believe this, I believe this, that more real-time and more accurate information makes for better decisions at the field level. Warwick knows that, Brandon knows that, I know that. The question is how to get that translated to the average grower in our neck of the woods. We oversee a district that is 3.5 million acres, about 500,000 of which are irrigated. Those irrigated acres are required to be irrigated. We get somewhere between 8 and 14 inches of rain per year. We are primarily growing corn, alfalfa, sugar beets, and dry beans here, all of which take a pretty significant amount of supplemental irrigation water. On top of that, we have a nutrient management problem. We've got nitrates that are growing in certain areas. It is not uncommon for one of our observation wells to show us well over 10 parts per million, maybe up in the 40 to 50 parts per million neighborhood. So understanding that all of this is important, there is some challenges. Our district has been a pioneer in the use of real-time telemetry for about the past 5 years. We have about 800 units out in the field right now where you can gather real-time information on what's going on your field. Not only how much water has been applied, but we can utilize soil moisture probes or small, tipping rain buckets, that sort of thing, as part of that telemetry package to find out what's happening so you can make better decisions. Guess what? 8 individuals, 8 farmers are actually using that real-time information out of 800 units out there. So there is an enormous disconnect. To your question, Dr. Neale, or as I might call you, Christopher, to your point, Christopher, we have routinely, we are big advocates of outreach. We do outreach all the time. We do producer roundtables every winter. I think we're one of only a handful of NRDs that do that, where we gather, large groups of people into a Quonset and talk about this and feed them some dinner. That is the best way to get people engaged in this. The on-farm sort of peer-to-peer work that DWFI and Extension are doing right now is critical. People like to talk to other people with dirty boots, not with shiny shoes. And with all due respect, because I know there's a lot of shiny shoes on this screen, including my own, people like to hear from people like Rorick and Brandon about what it is that they're doing, so that not only can they compare and contrast, but they can brag. I think the interface that NRDs have an opportunity to be a part of, or conservation districts in the other states that are represented on this call, are utilizing competition. Not unlike what has gone on with the TAPS program here at the University of Nebraska, but we could use a yield competition. We could use a reduction in nitrogen use competition. We could use a tax rebate program on those people that live under a specified allocation of irrigation water. Those things are doable, and they will drive usage, I think, at the ground level, particularly if you tie to it some sort of certification process, some sort of end user marketing piece. I love what you all are doing. I think it's tremendous. I think that is the challenge. And I think that challenge is meetable if we sort of focus on ways that we can engage these people, and not just a business aspect. How do I improve yield? How do I reduce input costs? All that stuff. And I'm sorry to say this, but we got to make it a little bit fun too. And I think there is an opportunity to do that. I'll mute now.
Thank you, John. I was having a problem unmuting myself. I want to go back and ask Rorik and Brandon. I presume, I know you have irrigated acres, but you might have rain-fed acres as well, right? And so the question is, do you manage your nitrogen applications differentially, whether you're on a rain-fed or in an irrigated field?
Absolutely. And in fact, I think I've been a part of the nitrate policy task force in Nebraska now for 2 years. And I think it's unquestionably probably one of the greatest challenges that we have as a state is figuring out what that process looked like. John just led us into that conversation is how do we make this engaging? How do we figure out how do we get adoption and move the needle in a way that makes the most sense? So absolutely, is 1.2 pounds of nitrogen and fully irrigated a realistic option in today's production world? First, if you put the economics with it, the cost of pumping that gallon of water, the cost of a nitrogen unit a year ago was roughly 30 cents a pound. Today it's $1. And so all at once you have to think in terms of what that means to your economic or ROI in terms of the stewardship and conservation, not simply your profit, but more as how do you start to think in your operation back that way? This tool would help some of those things, but I think you got to ask a bigger question of if you're pulling out specific segments utilizing this tool without recognizing the total system, which I think is where you're attacking it, and trying to activate that piece. I think that we're probably missing a few steps here that I think would really help narrow down the scope of what you're trying to accomplish. But that is also, I know it's year 1. So what is year 2 and year 3? That second or third date, I guess. And then what's the mortar between the bricks? Because actually you are building the building right now, but you know what will take that to deliver it to what John suggested is a TAPS-like competition, is in efficiencies and ROI, and a compelling continuous improvement process. Jonathan talked about sustainability. I dislike that word. I don't think that it's in our own operation. I want to look at it more as a stewardship and conservation initiative that puts us in a continuous improvement. And I'll leave it at that. I think that's in terms of where we're all headed, but to simply just pull it out as a specific segment, that makes it tough for a producer and it pigeonholes some, and it creates a bit of a barrier for adoption. And I'll mute, John.
So Brandon, do you want to add to that? And I might pose an additional add-on question to you. One of the aspects of Dawn is the forecasting tool, right? That's going to be part of it, right? Where if you knew it was going to rain with a certain probability in 3 days or in 5 days or in 7 days, how would you manage your nitrogen differently, for example? So go.
Yeah, that's a great question. You know, first of all, on our farm, we're basically 100% irrigated, but that means we still have pivot corners at our dry land, and we always manage those different. Make sure we're putting on more of the nitrogen that relates to the projected yield on those fields. Where I see this being beneficial is that if we could predict rainfall, if we could predict when it's going to happen, you know, we could really look at honing in on some of those processes that we're doing on the farm already. Part of our goal is to put a certain amount down ahead of planting. So maybe it's based on some research we had done through on-farm research, you know, maybe 75 pounds to 100 pounds of N up front. Well, then maybe we can time the back half of that better. If we know that there's projected rainfall or a rainy period, we can get it ahead of that rainfall so we can utilize that in a growing season better. Being able to manage the irrigation aspect of, well, looks like I need to run my pivot, but if we have a process of really honing in on if the rain is coming, maybe we hold off 2 or 3 days, which in our case is probably not going to make or break the crop if we delay that irrigation process. And we've done some of that instinctively on the farm, like looking at weather forecasts saying, I know the agronomist said to start it, but we're not going to do that because it looks like we're going to get rain. Let's manage it accordingly, because I don't want to lose the water that I'm spending money on. And I want to be able to grab the water that's coming out of the sky as well. And so it becomes a great process, that a great tool that we can utilize on the farm on our own operation. You know, we're not a huge operation. Most of our stuff's really close together, so we can manage it a little better. But if we can start to really dive into those areas, I think we can do a better job of reducing our nitrogen load, of better utilizing our water from irrigation sources as well.
Yeah, I want to add in that this is exactly what the irrigation scheduling is doing, like Ximing Cai and Chris Neale. So we incorporate both as a predictive skill for the next 2 weeks come, and also know we have the running the crop. We know also how much the water actually be demanded by this crop in the next 2 weeks in potential, and then put all these together to give you a suggestion of what is option to taking irrigation now or next day or later, which also will be a cost effective related in that way.
I'd have one comment to that quickly is we have managed from 1 day load control all the way up to 7 day load control now as a result of soil moisture probes and weather stations, and that is a consideration. So in your model, when you start looking at 7 straight days of being off 12 hours, basically from 10 a.m. to 10 p.m., that changes the model as well too, in terms of what your well capacity and resiliency is to capture that or anticipate that. So if that happened to play into that Don model, I think that have some value as well too.
Yeah,
I
Rory.
think Ximing can add it into that. This is where we actually incorporate. So in his model, we actually ask the farmer to feed in the information, the soil moisture, for example, sensor, and that will data assimilation to improve the forecast of the next coming days. And the forecast, as I said, it's not just 1 day. Okay, we are progressively doing every day update. So when the new information comes, that scheduling will change as well.
Yeah, we did some research before by testing different lengths of forecast, starting from like 3 days, 7 days, and 14 days. And we found out, I mean, that's kind of old research, based on the uncertainty involved, anyway, if the forecast is longer than 2 weeks, it does not make any sense. Anyway, so we try to identify, given a forecast scale, we try to identify what is the how many days forecast we could use, which could generate helpful information.
A high level of confidence in 7 days would be really, really helpful. Really helpful. Beyond that, it's tough.
Yeah, that's right. Yeah. I just want to say a few words about the novelty of this project. So many people are doing measurements, remote sensing sensors. Many people, a lot of people are working on models or predictions. But just ask ourselves, how many of those measurements, observations, or modeling results are really used? Not many. So in order to get them involved, really used, or to be truly useful for end users like farmers, so there is a lot of work to do. So that's why our research team needs to work with the extension. At some point, our education team will also have some impact on farmers and kind of make them understand some information would be valuable.
I have 2 things to that. Is Brandon said it best, there is a ton of silos of information and technologies that are being put in front of us nearly every day, and they come through our office door nearly every day. and the next available process. But yeah, I think it's important. I'm a third generation. This is my 40th crop, and my son, he's in his 10th, and as a fourth generation. But if we can't put it in the palm of your hand and basically have a red, green, yellow type of opportunity and prioritize those fields. In other words, Brandon said it best. If I have 60 fields, doesn't matter what size they are, but it's 60 different fields that I have to look at, then you better be able to set your stopwatch, and it better be at a glance that the compelling part of your dashboard needs to direct us, to send us to the ones of whatever that criteria or prioritization that you develop out of the Dawn project. We need to be able to customize that to a regional basis, which I see you're trying to accomplish, but then allow producers like myself and Brandon to be able to say, hey, I want to be able to look at what this means to us and move that decision as well too. So I'm just answering your question, Melissa, what you wanted to be able to tell the shiny shoes, and that literally is it, is a compilation. Tackling a dashboard it's a big one here, because without some type of customization per person, per region, that's a tall task.
Yeah, I think, Robert, it's really important to talk to you guys, and that's where we started the whole project of trying to engage the stakeholders to tell us what you want to do, and we can try to make it work. And at the beginning design, we are centered on centered our design of the user's need. For example, you have so many data measurement sensing, and as Ximing asked, have you allowed the others to use your data so that they can integrate your data into the model decisions you are going to use? So that is where the two-way interaction between the stakeholders and the modelers can really working together to develop some specialized tool you can have. So if, for example, you are working on your field and you measure soil moisture and you entered into dashboard, here is what the soil moisture will measure, tell me what is the next schedule for irrigation. Then that's where the Dawn, like Ximing's group, will say, okay, assimilate your data. I'm going to tell you, because giving the rain forecast that we have and your soil moisture condition in your field and also your crop growing condition, what we are suggesting, these two kind of scenarios you can choose. So something like that is a two-way interaction will be very, very crucial for the success of the Dawn.
Yeah, good point, Liang, and also remembering again that there's a wide range of farming, right? Where some farmers have all those sensors and whatever, and others don't. Others are irrigating the way they learned from their grandfather, let's say, right, or so forth, and they're doing business as usual. And we must not forget the observation that Rorik made about load control, where literally the power company can turn off your pivot, okay? And so that puts you behind if you're needing to irrigate, and it's the hot time of the season, or it's a critical time of the season, like when corn is pollinating. I mean, these things need to be captured. In addition to that, there are wells in Nebraska, right, because of the water table going down and so forth. They just don't have the capacity, right? And I think Brandon and Rorik could comment, and John, they don't have the capacity to keep up with the demand. Isn't that right, John, for example? So these things need to be incorporated in this logic of Dawn. And we do need to do some events and bring farmers together this winter to have these discussions so we can capture all this knowledge and build it into the Dawn decision support to make it more useful.
Yes, and that's on that end, I want to add that this is where we call the system modeling. We are actually trying to take whatever this information in a larger scale way from the remote sensing data, from the weather forecast. For all these, we are integrating the model first. And we use the default controlled availability, for example, the water, so groundwater, and then to simulate what it will be taken if so many people is using the same area of the aquifer, how that water supply will be concerned. And all that is supposed to be in the big system dealing with that. So, but again, still need the feedback from the user's point of view. If you are using this and you have these sensors in your field, and if you're willing to share your experience using the data, and then the other farmers in your neighborhood, they could share the similar information even though they don't have a remote sensing, because the model calibrated by your field will produce a better result for the region around you.
John, you unmuted, so I'll let you go ahead and comment because you were about to say.
Well, Christopher, two things. I would be glad to host a big meeting out here of, the wide swath of different kind of producers we've got. We still have people that use flip phones here, and then we have people like Rorik who, have the latest and greatest attached to their belt. We also have 50-year-old pivots, to your point earlier. We have people with VRI panels. We have people with the original panel that was installed in 1960. So I think that this tool, sort of to the point that Dr. Liang was just making, this tool can be useful to both types of producers. You don't have to have grid VRI technology. You don't have to have your field even EC mapped. Even if you were making a better irrigation timing decision based solely on forecasting or solely on a moisture probe that may be out in your field, you're better off than you may have been otherwise. And so I think having that discussion, understanding that there are people that are going to be able to use this technology to the same point that they may be using FieldNet or some other technology, subscriber technology in their fields today, as well as those that don't have anything other than, as you put it, the way their grandfather told them to irrigate. We still have a lot of people like that. And we have a varying, varying size of farms, varying equity in farms, varying ability to even play a role in our cost share program. It's hard to cost share with someone who cannot share the cost, given maybe their financial challenges. So back to the point that you were making, we do need to make sure that we understand that there is a wide spectrum of agriculture people, not just in Nebraska, but all over the place. And I would be glad if this group or some subset of it wanted to do a meeting over the winter. We generally do our big producer roundtables in January and February. We usually get 200-300 people in a room. That might be a nice start. So
great, John. Thanks for the offer. We're getting close to the end, but I do want to discuss one more subject here that's in the chat box, which is sharing data, right? What's your view, Brandon and Rorik, as producers on sharing some of your data for research, and how do you, and this question goes to John as well, typical colleagues of yours out that are farmers, what are their view of sharing their data and the time it takes and the and privacy and all that? Go ahead and comment, any of you, on that topic.
I'd say we're probably a little bit of the anomaly out here, is that we're pretty willing to share data. Those of us who've been involved with any sort of research projects or understand the importance of collaborative approach. So, we've been pretty open with most of our data, obviously not financial type data. But if we're trying to talk ROI, probably institute some of the data they need for that as well. I think there's a lot of people that get leery of it because they don't know who's going to be doing what with the data. But when we start talking, the way I've approached it is, if we're talking irrigation usage, nitrogen amounts, yield, any of that important stuff, that it's not that big a deal. We're not trying to hide any secrets out here. We're trying to figure out how to make things better. So that's been a little bit of our approach over the years. And I know, maybe Rorik's got a different approach as well.
Nope, straight up transparent. I'm the same way. Financial data, obviously is is probably off limits, but in terms of an ROI or building a profitable acre, absolutely. Soil moisture data, weather station data. I think you're spot on in terms of but you're also picking on two, as John would put it, got the shiny stuff sitting in our shops or in our fields. And so you flip that around, and that reluctance to share data, even if they're producing data. I mean, it could be only just through My John Deere or through Trimble, simply just collecting field activities as planted. I mean, those are the kinds of things that some people just don't put value in that data yet. But now you've got providers like Nutrien or Simplot or Helena. I mean, there's a lot of the co-ops are building very robust tools that obviously keep producers in their coming back to their facilities to purchase inputs. So I mean, there's data abounding. Jonathan stated earlier about a petabyte. You know, we're in a couple terabytes a month in what we're producing, and we're asking anybody we can find to help us with that data. So that's a tough one, Christopher and group, to really think that in a big scheme of things that you'll be able to get enough relevant data. John, I don't know, what's the policy on sharing water data? You just aggregate it, I think, don't you? You don't really even break it down to even sections or anything, do you yet?
Yeah, we aggregate it by county generally. If we get a more specific question than that, we will break it down further. You know, if somebody's looking for Warwick-Pullman's water usage information, I would have to get a release from Warwick-Pullman to provide that. There are ways around that, of course, and there are ways that we have addressed that even publicly. Many NRDs publish, you know, sort of a color graph overlaid on a map. So you generally know where Warwick's farm is. You generally know what color his water usage is. It's sort of a 2 cute by half way of sharing data. I will tell you that people in our neck of the woods, in our 4 1/3 counties that we represent, are pretty used to sharing data with us, and they're pretty open to sharing it with others. Again, all the way across that spectrum. And I really think that's because we've dealt with some of these water usage, land usage, different tillage practices kind of questions early on as we were building a regulatory scheme here, so that it's just a matter of course. You know, I will go out onto Brandon Farm, let's say Brandon Farms down at Malbida. We can go out onto Brandon's farm. We can do a field inspection. We're going to read his flow meter. We're going to talk to him about his practices, and he's going to get pretty comfortable with our staff sharing that information. Now, sharing it beyond that, you know, that would be a discussion that we would have to have with individual landowners. We've got those kinds of landowners, sort of like Rourke, that are saying, Rourke and Brandon, that are saying, oh, this is fine to share. And then we've got others that, you know, treat it as if it's state secrets. I don't really have much of a concern about it. We do it routinely, but we do have little policies in place to protect those that want to be protected.
Well, thank you. It looks like we're coming up on 15 minutes over the allotted time. I think we should probably end the session. I really enjoyed the discussions. I think this has been very productive. Thank you, Rorik, John, and Brandon, for your insights. Thank you for all the presenters for laying the project out. And thank you for USDA NIFA Sustainable Ag System Program for funding this effort. And we hope that over the course of the project, we will be able to generate a lot of good information and a decision support tool that farmers can use, and it can have an impact on the ground. Liang, would you like to say some final words?
Yeah, I just want to thanks Chris setting up and give us the opportunity, and also thanks John and Brandon and Rorik to really discuss with us what you need. And this is an engagement we really need to, in the future, hope we can work with you more closely to get your need into it, and so we can design the better the Dawn decision support tool. So really, thank you very, very much.
Very good. And remember, this has been recorded, and we will be providing a link so that you can review it. And I hope everyone's okay for us to divulge this information on our website, right? I think it's important to get the message out there that this could be a part of the process. Okay, thank you very much
Thank
for
you.
everyone. Have a great rest of your day.
Yeah.
And I presume Brandon and Rorik are going to go back into the harvesters with their teams because they're in the middle of the harvest season, right? Yep.
Thank you.
Okay.
Thanks.
Have a good evening, good afternoon, everyone. Bye-bye.